This video will introduce a useful software tool, Embedded Target. It can help developers reduce both testing time and costs in model-based development. I'd like to discuss model-based development. Model-based development is a software development methodology based on the V-cycle. The model-based approach enables a developer to simulate complex control processes. These software models can be tested at every stage to assess their performance in real time. This way, the product can be verified and confirmed before the code is generated. Once the software model has been finalized, the code can be generated automatically from the models, using code generation tools. The generated code is tested on an evaluation board or MCU simulator. Verification can be implemented during the module design phase. Before the code generation, tests can be performed using model simulations in a virtual space. This simulation is called a model-in-the-loop simulation, or MILS by model-based developers. After the code generation, test can be performed using simulations at the module test phase. This is called a processor-in-the-loop simulation, or PILS. In a normal V-model development, when errors or defects are discovered during PILS, the developers must return to implementation phase to fix the code. However, in the case of MBD, the developer returns to the module design phase, as indicated by the arrow. The modified object are the models, not the code. As a result, developers need to find a way to perform this process effectively and efficiently. A proven method is carrying out MILS and PILS at the same time. In this way, once the module design has been completed, MILS and PILS are started at the same time, and the results are then compared. Next, the model is modified until the differences meet the requirements. MATLAB, the representative tool of MBD, makes this possible. Simulink, the model design and simulation tool, executes MILS. Embedded Coder generates the code for embedded systems. This is helpful for porting code to embedded systems and for the implementation of PILS. However, the embedded coder can only generate module code, and cannot create a system or peripheral drivers. Therefore, the developers must port the generated code to an MCU or system. But this operation is time-consuming and must be repeated every time PILS is performed. How can this problem be solved? Through the use of Embedded Target. When faced with such a problem, we recommend Embedded Target, which can eliminate this workload. Let's move on to an explanation of Embedded Target. The Embedded Target supports MBD Developer with these features. First, Simulink and the Renesas IDE are connected to create an environment in which PILS can be immediately executed on a Renesas target board or simulator. Then Embedded Target will return the execution result of PILS to Simulink for easy comparison of the MILS and PILS results. Embedded Target works in the following order. First, duplicate and configure the model for PILS. Then, code for the Renesas MCU is generated by calling the embedded coder. After that, the generated code is inserted into a Renesas IDE template project. During this operation, generated code from the embedded coder can be built and executed immediately. Next, the Renesas IDE for importing the encapsulated project is started. After this operation, a communication channel is established to exchange data between Simulink and the Renesas IDE. Finally, PILS is run by building the project in the Renesas IDE and debugging with an MCU or simulator. PILS result will be transmitted to Simulink. Embedded Target has three features. Firstly, Embedded Target can create an automatically configured model for the PILS environment. Next, it generates a Renesas IDE project for PILS. Finally, model verification is performed by checking the execution time on an MCU or simulator. Through these features, Embedded Target helps developers reduce MBD development time.